Hello everyone, welcome to lesson 7-1, first lesson of chapter 7, Congruence and Transformations. For this lesson, we're going to, or I guess this entire chapter, we're going to try to answer the question, how can you determine congruence and similarity? Let's look at a real world example. Braille. The letter R in the Braille alphabet consists of 4 large dots and 2 smaller dots in the pattern shown. Circle the letter with the same shape as the letter R. So here we have the letter R, and we have 4 large dots and 2 smaller dots. Okay, which one has the similar shape? We can see here that we have 4 large dots right there and 2 smaller ones, except it's mirrored, right? It's a mirror over the y-axis, correct? We got to ask ourselves, how do we determine that? Well, how can you determine whether 2 figures are the same size and shape? Step 1. Copy the figures shown on tracing paper 2 times. Cut out both figures. Label the figures A and B. As you can see here, we've cut it out and we're going to label them A and B. Place figure B on top of figure A. Are the side lengths the same? The angle measures? Okay, are they all the same? Well, if you cut them both out and they are exactly the same and you can see that there are no overlaps or anything sticking out, then you can simply say yes. So we would write yes for both, right? Are the figures the same size and shape? Yes, again. Right? Okay, let's see here for step 3 and step 4. Again, we're trying to identify if the shape and size are the same. And we can do these different tests. So translate figure B up and over your desk. How can you move figure A on top of figure B so all sides match? So all angles match? Well, you would have to do the same, correct? I would say translate figure A in the same direction and by the same distance as you slid figure B. Just match the same motion and translate it the exact same way so that they match. In step 4, flip figure B over. Okay, so now if you flip it over, rather than slanting this way, it's going to slant this way, right? So flip it over. How can you move figure A on top of figure B so all sides and angles are the same? Same thing, you can flip over figure A the same way. So you can flip over figure A the same exact way. What's the point? What's the point of this entire example? Is to show that when you, in order to solve to see if patterns are same size, shape, and angle, you can try to rearrange them and try to match them to see if they are. Because essentially we're trying to identify congruence or similarities. On the previous page, you matched figure A to figure B by translation and a reflection. 2 figures are congruent if the second can be obtained from the first by a series of rotations, reflections, and/or translations. In other words, if you can move it around and they both create a match, then there is congruence. Determine if the 2 figures are congruent by using transformations. Explain your reasoning. Here we go. So we have these 2 right-angle triangles, or they look to be right-angle triangles. We would need to possibly rotate it and flip to see if it would fit in here. Let's see how they do it. Okay, for step 1, we have triangle ABC over a vertical line. Okay, so what we would want to do, you can see that it's a reflection over the y-axis. Okay, and when we translate it, when we create over the vertical line, we get the same shape now facing the same way. Okay, so that we have the new image. Step 2, translate ABC until all sides and angles match. You see that? Okay, so the 2 triangles are congruent because reflection followed by a translation will map. So a reflection by a translation, and then it needs to be moved. They'll match perfectly. Okay, example 2. We have these shapes like Tetris. reflect the red figure over the vertical line, over the let's see, if we were to reflect it, will it work? Well, let's take a look. Here we have like an L and then a backwards L. But immediately, one cube up, we have this. This one is 2 cubes up. So you see that this little cube there is not going to match. Reflect the red figure over the vertical, so we reflect it over, and we see that when we try to put them together, they're not going to match. Okay, that's not going to match that. Even if the reflected figure is translated up and over, it will not match the green figure exactly. The two figures are not congruent. Okay, let's try it. You might be able to do this just simply by looking at them, but we do have to explain what we have to do first. We have to do a translation or a reflection in order to prove that there is congruence. Here we have two parallelograms, okay, A and B. If I were to make a reflection of A, it would look something like this. And you can see now that it matches this new mirrored image. Now matches my B a little bit better. So now that I have created a reflection, now I should make a translation to see if it would fit perfectly over that. So if I were to carry it over and place it on there, you can see that all the lines are going to match perfectly. So is it congruent? Yes, it's congruent. A reflection followed by a translation maps figure A onto figure B. You can see that if I were to translate it, it would fit on there clearly. Translate means moved as is without rotating it after a reflection. Let's try that with B. With B, if I were to take this image here and try to perhaps rotate it, I could do a 90-degree rotation to see if it would fit, right? So I would just take it, right, and try to do a rotation of 90 degrees from the origin, and it doesn't match. You can see there that it would match. What if I were to do a reflection first and then try to rotate it? So if I place it here and now I create a reflection of it, as such, I can try now to create a 90-degree rotation. Again, I will bring it here 90 degrees from the origin, and again it doesn't match. So there is definitely no congruence. Not congruent. No transformations will match the two figures up exactly, even after a reflection. For our second key point, we're going to determine the transformations. If you have two congruent figures, you can determine the transformation or series of transformations that maps one figure onto the other by analyzing the orientation or relative position of the figures. So we have translations, reflection, rotation. We've practiced all of these in the previous chapter. And I know that many of you are very comfortable now with these concepts. So translation is moving from one to the other. It doesn't change the size or the angle. It's just simply, it's a photocopy of it placed somewhere else. A reflection can be over the y-axis or over the x-axis. You can see that this one's over the y-axis. The points are close, matched up, while the other ones aren't. So it would mean that the x-axis would be, in both of these points, would be the opposite. Be converted to the opposite because it's moving in the opposite direction. And then a rotation, this could be a rotation of 90 degrees, perhaps, from the origin. Okay, so actually I'm just estimating, I'm not 100% sure, but you can see that a rotation moves around from the point of the origin, around all four quadrants. So now that you have that, let's take a look at the example with real world examples in creating names and logos and whatnot. Ms. Martinez created the logo shown. What transformation did she use if the letter D is the pre-image and the letter P is the image? Are the two figures congruent? It looks that way. It looks like she simply took the letter D and she did a full 180 degrees, change the color. You see that? 180 degrees. And change the color to make it look like she drew a new letter. Start with the pre-image. Rotations or reflections change the orientation. Rotate the letter D 180 degrees about the point A. Okay, so the point A could be our origin, but it's from the point, this could be our 0, 0, and it's being rotated clockwise 180 degrees. And there we have it. Okay, but notice that if we were to rotate it, then it has to be translated and moved up to match. Translate the new image up. You see that? Okay. So Ms. Martinez used a rotation and a translation to create the logo. The letters are congruent because images produced by a rotation and a translation have the same shape and size. Okay, here we have another logo. Okay, kind of looks like we have M and W. Let's take a look here. What transformations could be used if the letter W is the pre-image and the letter M is the image? So we have W is the pre-image and it's going to be rotated. Okay, we can rotate it from this point, from the point, we create a point there, and then we translate it by moving it down slightly. Okay. Are the two figures congruent? Explain. They look quite congruent just simply by looking at them, but let's see. I could do a rotation, okay, of 180, which would flip it all the way around, counterclockwise or even clockwise, but I'll go counterclockwise in this direction, okay, and if I did that, it would look like that, right, all the way up in the top corner, right there, right there, something like that, right? That would be after a 180 degree, and then I would have to translate it and move it down so that it can match like that, right? That's what we would want it to look like. Another option, which doesn't have to include a rotation, would be to create a reflection over the x-axis. Remember that the x-axis is horizontal like this, and if I created a reflection, then it would give me the automatic 180 degrees. So it would look something like that, okay? If I created the reflection, it would look something like that. And then I would have to create a translation, just shifting it over, it would look like this. That's translation to shift over like that, right? So that's the idea. Either one of those answers is fine. I decided to use the second one, so a vertical reflection over the x-axis followed by a translation. The images produced by a reflection and a translation are congruent. Okay, and that's today's lesson. Here is what we will start class with next class. So go ahead, read through the content, make sure you feel comfortable. You can always reflect back to examples 1 or 2, or even example 3, the last one we just did. See you in class, everyone.